In this video, we're going to talk about condensation polymers and the exact exam style question. So this is the one where you stop the video, do the questions, look at my explanation. So we're going to do the first one on repeating units. And repeating units is a very, very common question where they ask you to do a number of repeating units when they give you usually the structural formula, just like we've given you here, of the monomers. Okay, so you have to convert those to a set of repeating units. And you can do them usually in any structural formula you want to do. So for example, structural formula, skeletal formula displayed if you like. Now I want 3 repeating units of this polymer. So let's move it over to the side. Let's first of all recognize what it's going to be. So we can see there is an acyl chloride here, COCl, COCl. So I've got an acyl chloride and I have got a diol here. Okay, I have 2 carbons in the middle, okay, and 1 carbon in the middle of these acyl chlorides here. So first thing, it's quite important to realise what the 1 repeating unit would be, and then we'll just repeat the whole thing 3 times. Okay, and they're asking for repeating units, so it does end in open bonds, and I'll show you what that means in a minute. Okay, so but first of all, here's our acyl chloride. So you've got the acyl chloride there. Okay, and our acyl chloride has Cl coming off there. It bonds with your alcohol. Now your alcohol, okay, is, if you look here, 2 carbons in length. So I'm just going to draw 2 carbons in length. And I'm going to say, remember the H leaves, if you're reacting an acyl chloride, the H and the Cl leaves. So I'm just going to draw a bond to that, okay, and then a bond again. There you have your 2 monomers, okay? And we're just trying to realise what is the actual repeating unit so I can do 3. So I get rid of the HCl because it's a condensation reaction. So I've got rid of my HCl and my HCl here. Okay, so I've got rid of 2 HCl for there. And then take my pen and just go, right, okay, let's join it back up again. And then these are the ends of the repeating unit. So this is the bond to another repeating unit. Okay, and you've got 1 repeating unit. Okay, so 1 repeating unit. So, but we have to draw 3. Okay, so much easier to do in skeletal, I believe, than it is to do in structural, but you can do it in structural as well if you'd like. So all I do is then draw that 3 times. So I'm going to draw that 3 times. So here we go. Let's start. It's going to be long. So let's do it. See if you can do it before I do it. Okay, and all I'm going to do is copy that picture that I've got up here. But I'm going to join on 3 times. So here we go. Okay, and there is 1 repeating unit. Can you see that? So it's 1 repeating unit. Done. I then have to repeat the unit. So I have to take that and then put it on again. Okay, so that means I'll go to another one. Again, I'm just copying this whole section. Okay, so copying that whole section here again. So I'm going to take this bit here, okay, which is our first repeating unit, and then just repeat it 3 times, okay? So I'm going to go down again, and here is our oxygen. Okay, and you'll find again I have repeated that a second time. Okay, so I've done 2. You say they look exactly the same. One might be pointing down, okay, but they're still exactly the same thing. Okay, and then I need to repeat it again. Okay. No. Okay. There we go. There's my. And I have repeated it again. Let's just get rid of that. Okay. So I've repeated it again. You'll find I've got 1 repeating unit, 2 repeating units, 3 repeating units, as you can see like that. I've just got to finish it off with a bond Okay, because these are repeating units, you have to have those open bonds because we're just drawing 3 repeating units of a larger polymer. So we're just not drawing the rest of the larger polymer, we're just drawing the 3 repeating units of them. Now I've put the brackets in here, but you don't. I did that to show you that each one of those is a repeating unit. I wouldn't draw the brackets in the exam, I'd get rid of the brackets. So it should literally just be like, let's get rid of that one, get rid of that one. Okay. Okay, so that's literally should just look clean like this. No, it's not perfect. No, let's get rid of that. Make it a bit nicer. It should look clean. So don't put the brackets on. Just leave them without the brackets. But that is how you draw different numbers of repeating units. Okay, remember it's usually 2 or 3. So draw out the 1 repeating unit first, and just copy it as many times as you want. And remember, leave it open because it is a part of a larger polymer. Okay, and leave it open at the end. Our next question is an exam style question on repeating units calculation, which often comes up. And I want to show you an easy way to navigate this question and do it. So the question shows you it's a polyester. So it's formed from 100 molecules. So the rule here is if it says polyester and it gives you an exact number of molecules, you know that they form condensation reactions to form a polyester. But because it's an actual molecule, it's not a repeating unit, you do not react the ends. So you do not react the ends. So a polyester is formed from 100 molecules of 2-hydroxybenzoic acid. That means that every single time I do an esterification reaction, I will remove the water, but I won't remove a water from the final ends. Okay, because normally you would have the repeating unit that goes out and you take away the water from there. We'll show you what this means pictorially. So let's just move this across and then highlight the main areas. Remember, we were calculating the relative molecular mass of this polyester if there's 100 molecules in it. So the first thing is, if I put it up here, let's draw the molecule out, okay, and you have got your carboxylic acid, okay, and then you've got your hydroxy at number 2. You can work this out, please do work it out, but the molecular mass is 138. And one of the biggest errors that people do is they'll calculate that wrong because you're under some extreme time pressures. Totally understandable, but be careful when you're doing it. So that's 138. So that means your initial thought is to say, right, we're going to do the molecular mass of this polyester. So our molecular mass of the polyester, okay, so the molecular mass of that polyester, okay, is going to be equal to 100 molecules. We think it's 100 molecules because we've got there, times 138. And that equals 13,800, so 13,800 grams per mole. Now that tells us the mass, okay, so that tells us the mass of all of the molecules. But we know for every single molecule we have, we are going to lose, or every 2 molecules we're going to lose a water. Okay? So that basically means as you go along, you can kind of extrapolate that out if I give you a little example of 2 molecules. So let's do 2 molecules and just draw 2 molecules. Now if I've got 2 molecules like this, there's my acid. It's going to form an ester with the alcohol on another one of these. Okay, so there you go. There's the benzene again, and I just have to finish off this by on this one, because it's the carboxylic acid side, drawing my OH. And on this one, there's the OH, so I'll draw the carboxylic acid here. Okay, so I have drawn carboxylic acid, 2 molecules, okay, and you notice that here I have 1 ester linkage. 1 ester, that means that's going to have 1 water being lost, okay? So I've got 2 molecules, 1 water being lost. Because it is a polyester with a discrete amount of molecules, the end of it, as you can see here, okay, and here, okay, you can see it's unreacted. And that will happen with 100 molecules as well. So if we go across to here and we say, right, okay, what does that mean then? What's the molecular mass of the H2O that we've lost? Well, the molecular mass is going to be, we've got 100 molecules, but remember, there's one, the end parts do not react, so that means we don't have 100 waters, we have 99. Okay, because of that, we can do 99 times 18. 18 is the molecular mass of water. Okay, so just remember that. The other molecular mass you need will be of H2O. So H2O equals molecular mass of H2O will equal 18. Okay, so that's where I get that number from. Okay, so 99 times 18, 99 being one less than that because that water from the ends is not created. That will then equal 1,782. That's my total mass of the water that's kicked out. So all I do, if I want the MR of the polyester, okay, all I have to do is do 13,800, okay, minus 1,782, which will equal our final answer, which is 12,018, okay, grams per mole. So what's really, really important is that you just remember the end hydroxyl and the end carboxylic acid, because it is a molecule, do not react. That means you have one less water than the number of molecules that have reacted. So you don't calculate 100 times 18, it's 99 times 18. Take that away and you have your final answer. And they can do this with many different examples, but this one hopefully will mean you always get it right. Our next question is possibly the most common question you're going to get, which is drawing the repeating unit, just one repeating unit of the entire polymer. Now, we're going to take A and B and react them to form a polymer, which is most likely how it's going to be presented. And you draw the repeating unit of that polymer. So A is this benzene compound with 2 carboxylic acids on it. And then B is a diol, so 2 alcohols. So the alcohols are going to react with the carboxylic acids. They're not going to react with the OH. That's just a distractor. Okay, so let's make some space. Put it down and to the side. And then what we can do is look at our 2 monomers and put them together. So first of all, let's do the benzene, and then I'll draw it just like it is there with the 3 double bonds this time. We've got that, and then we've got the carboxylic acid. So the carboxylic acid makes an ester, remember? So I'll make an ester from it. So this carboxylic acid here is going to react with this alcohol here. Okay? Loses H2O, and that means I'm going to lose the OH of this one. So this OH that I've underlined is going to be gone, and then we lose the H on this side, okay? So that will be gone. So all we do is draw it again. There's our O, and then we've got our O from the alcohol up and down, and then back to our O again. Now, at the same time, this H is gone, so this H that you can see right here is going to leave, okay, and this OH that we've got down here is also going to go. So you get these 2 waters essentially. Now, if that's the case, I then draw right there, but I don't draw this coming out because the OH is gone and the H is gone from here as well. And I just put, because it's skeletal formula, these dashed lines because I don't want to get it confused with the skeletal lines. Okay, and then finish it off with a bracket. And there you go. You have your repeating unit for these 2 monomers. And just remember, it's esterification here. You've lost the water and you lose your water from the outside because you're doing a repeating unit. If you're talking about a discrete molecule, you don't lose your water from the outside. If you're talking about a repeating unit, you do lose your water from the outer edges of the repeating unit. Our last exam style question is on drawing the monomers. It's very common. and so good to practice. So draw the structure of the two monomers. So you already get the fact there's two monomers from this condensation polymer. So this condensation means that it gives out water, which means that to find the monomers, you've got to put water back in. Okay, now it gives you a section of that polymer, and as you can see, looks very complicated. But first step is to look and see whether you can see any similarities. You want to know whether there's more than one repeating unit in here. Okay, so let's have a look and see whether there is. So if you look at something that's common, CH2, CH2, there you go, and then work your way backwards. Right, so I think this might be the starting point. So CO, CH2, 2, COO, CH2, 3, O. So we found that there are two repeating units there because they're repeated. So let's colour those in. And if we want to find out the two monomers, we don't need both repeating units. So I'm going to get rid of one of the repeating units. Here is our repeating unit, and let's see if we can draw our monomers. So if we look here, we're going to start trying to draw it out. Now, it's important here that we can recognise from structural formula where the esters are. Okay, we know it's a polyester, we know it's a condensation polymer. Okay, so if we know where the esters are, we can put the water back into where the esters are. Okay, so first of all, it's a fairly hopefully simple thing to see that that is an ester, COO. But remember, this is a repeating unit, so this CO would be over here as well. So that means you would have COO here as well. So that means this part here and this part here form an ester as well. So we've got two esters. But let's draw this in a more displayed type formula first. So there's the CO. This is the CO here. Okay. And then you've got the CH2, 2, and then that bonds again, COO. So COO, COO. Okay, so you've got your ester. This is your ester bit here, then your CH2. Okay, bracket CH2, 3, and then O. So you've got your repeating unit right here. So that's your repeating unit there. So then we look and we say, well, where is my esters? Well, we already knew that that was the ester right there. Okay, and if you think about it again, repeating unit, that would mean there would be an ester that was formed from this and this. Okay, so that means we've got to put water in here and we've got water in here. So we've got to put two waters in. And it's really important, if we're going to find the answer to this, two waters are involved. Okay, so we've got two waters. Now those two waters, remember, they're made of OH and H. Okay, so OH and H. The OH is going to go on our carboxylic acid side, and the H is going to go onto where the alcohol was. So let's just draw this again. Okay, so this time, this has got to be our carboxylic acid side, so therefore we're going to put an OH here. Okay, then we just copy it out again. And again, the C double bond O means it must be our carboxylic acid side, so we add the OH there. We'll then start again from where this O is. Okay, and just copy out. Copy it out from there. Okay, so we've got to the point, we've got O, we've copied this part out, and added our OHs, which means we've added these, we now need to add the H's to the alcohols. So if we add the H's to the alcohols, there's your alcohols there. Okay, so that means you have your two monomers here. You have your diol here, and you have your dicarboxylic acid here, and your diol here. And if you've done the previous videos, you'll realise you need that dicarboxylic acid and you need that diol to make your polymer.